This is the video for day 2, solving equations with variables on both sides. So this is two-sided equations right here. Okay, we'll start with the warm-up, giving an example of a rational number that's not an integer. So rational is one that has decimals or fractions, and integer is one that can drop them. So we're looking for something that's a decimal, like 7.5 or negative 7.5 is fine. Give an example of a rational number that's not a fraction. Well, no rational numbers can be written as a fraction if the top and bottom are integers. So you can just take a number like a square root that's not a perfect square. Perfect squares would just be integers. Or something like pi, that'll work. Okay, so these are a two-sided equation, and we have notes to take as well. Okay, so since we're talking about two sides, I'm going to put the line back for these couple ones. It's not mandatory, but it seems to be very helpful for a lot of people to talk about left side and right side by putting that line. Okay, so the first thing we need to know is our goal. We need to get the variable on one side, the x by itself, and the number on the other side by itself. Okay, so right now the x's are on opposite sides right here. Okay, so I'm going to have to move it. And the one who usually moves is the one with the smaller coefficient. 5 is smaller than 7, so I'm going to move that over. The reason I move the smaller one is if I do that, I won't get a negative x. So now this is the one where I add the opposite, so it basically zeroes out on the right side. Zeroes out on the right side, so there's no more x's on this side. So he's going to move this way. Okay, and 7 minus 5 is 2x. All right, then bring down the minus 2. All right, since the x have claimed the left side as their side, the numbers have to move. So I need to zero out the numbers. That's why I always add the opposite or do the opposite operation. Okay, so I get 2x equals 8, divide by 2, x equals 4. As far as notes, I would just say try to move the lower coefficient. It's not mandatory at all, but it avoids negatives. Okay, so now I have one where I'm distributing here. Okay, so I remember that from last lesson. I have to multiply by both parts. So 4x plus 2 equals 3x. Now, one thing it's very important to do, try not to zero out a side. So you see how this 3x is by itself? I'm not actually going to subtract 3x because what happens, and I'll put that in red, when I do that, what happens is I get a lot of this, x equals 2 over here. You see how that equal sign shifted? See, it's right here. It's no longer on the line anymore. It's supposed to be on the line. Okay, now if you zero out a side, if you make a side equal to 0, that's fine, but you'd have to just put the 0 here, but keep consistent. So this is actually, x plus 2, and that would be fine. Then you'd move it over. But we're going to avoid that altogether by not even touching the 3x. Instead, I'm going to move the 4x. And yeah, that's going to make a negative, but at least if the x's have a side to themselves, like that's where I'd rather go, right? So 2 equals negative 1x, and then divide by negative 1, and then I get x equals negative 2. Okay, so notes, try not to zero out a side. Okay, it tends to shift the equal sign. Okay, keep equal sign. On one line. Okay, and you have to draw that line, that's fine, to keep it on the line, but make sure they're all aligned vertically. Okay, check for understanding is yours. Okay, so when you're done, Call teacher so I can check your solution. Okay, so model problem C is what I would consider grade level. So now we're going to talk about the 3 steps in solving multiple equations. And I abbreviate this technique as DCM. DCM stands for distribute, combine, move. Okay, because that's the order you're going to want to do the steps in. So first, if there's anything to distribute, we do that. So I'm going to take the -5 over here and distribute it. Bring everything else down. And it's important to do one step at a time so that you don't get confused. Keep that equal sign aligned, -35. And don't be afraid to check your calculations on a calculator. Okay? In here, a couple of principles we talked about, like the double negative. Make sure you make that a positive 10a. Okay? Second is combine. Okay? Those are things that are on the same side. Same side always combines. Okay? Remember the blue? So if I have 2 numbers, they're just going to add together. I am not going to add the opposite. That's 4 plus 4 is 8. Okay? And the -6a. And on this side, I've got 1 and -35, -36, plus 10a. And that's the combined step. So they just add together if they're on the same side of that equal side line. Now the move. Okay? The move if they're on opposite sides. That means you're going to move on one side from one side to the other. Okay? And that is where you do the opposite operations. Not the distribute step. So, move the smaller one if you can. Okay, -6 is smaller than 10, so I'm going to move that. Okay. Always keep that equal sign in a line. So I've zeroed this out. Only 8 is left on the left. Here, -36. And 16a. So the a's have claimed the left. Now, -36. Opposite of that is +36. So let's do that. Okay, so that's 44 equals 16a. Okay, and then I'm going to divide by 16. Now, in the case where your answer does not come out even, let me tell you how it should look. Okay, so a equals 2.75, but you can always change that to a fraction. Okay, you want to press the math button to do that. And number 1, change to fraction, looks like this. Okay, so if you do that immediately after 275, math number 1, you should get 11/4, which is how oftentimes it's going to be presented to you on the regions. Okay, check for understanding. Very important that you check in with your teacher, with me. Why do I keep calling myself the teacher? Call in teacher. Okay, call me in for me to check your work. It's very important that you see me about this, okay? Okay, so the last section of this lesson is identities and contradictions. Okay, so an identity is something that's always true. A contradiction is something that's never true, okay? So an identity has infinitely many solutions. And what you're looking for is a true statement, okay? A contradiction has no solutions, and what you're looking for is a false statement. In both of these types of equations, the variable disappears, okay? You try to solve it, and it's not there anymore, okay? So basically, you're looking for something that's the same. Let me show you. So in an identity, you distribute, and you try to move the variables to one side, and you notice that they cancel out completely. What happened? Okay? Nothing. You did it right. You get something like 6 equals 6, which is true. All right, when that happens, you write, there's infinitely many solutions. That means that no matter what you pick, everything is going to work for x. Every single thing. If I put in 1, for example, 2 times 1 plus 6 is 8. And over here, 2 times 4 is equal to 8. It's going to work regardless. Okay? So this is all you have to write, infinitely many solutions, if you get a true statement. Okay? Contradiction is going to go like this. Again, same thing's going to happen. X minus x is 0. Variables are gone. Okay? Always look for the variables gone. The variable's gone, but this statement is false. When that happens, there's no solutions. Okay? Nothing makes it true. There's no number on Earth where that number is equal to 3 more than that number. It's just not going to happen. Okay? Now, that's not the same thing as saying x equals 0. Okay? Not the same thing. Okay? This is a solution. This is one solution, and that's the number 0. Okay? Not the same. So if you get x equals 0, 0 is the solution. It doesn't mean 0 solutions. So be careful about that. This is only when the variable disappears. If the variable doesn't disappear, that's really not the case. Okay, so go ahead and complete the exercise. Same deal. Call the teacher to be checked. And that concludes our video.